Hello, 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 cloud builders. Are you ready for the show? Did you make some warm, spicy tea or strong coffee like me to spend your time perfectly in this autumn evening? if it's cold or warm for you. And here, where I am in Oslo, Norway, it's quite good weather, so we can consider this autumn as warm one, and let's make it even warmer, even better. I'm Maxim Salnikov. I'm a developer engagement lead at Microsoft, and today or tonight in your time zone, I will host and moderate 8th edition of Build Up by Cloud Builders, and this is edition dedicated to DevOps. I promise you, you will learn a lot. You will enjoy the content and enjoy the discussions. But first, for those of you who attend Cloud Builders event for the first time, what is this about at all? Cloud Builders is a community for learning and inspiration. And our online events are headed by leading industry experts. So without builders, with the events by Cloud Builders, we help practitioners to solidify their knowledge and enthusiasm. We want to be very practical. We want to help you to solve your very practical problems you have with the cloud. So what's on agenda for today? Today, as I mentioned, this is DevOps edition with very strong focus on Azure cloud, on everything related to DevOps in Azure, but actually not only. So maybe the most practical knowledge you will get about Azure. At the same time, you will learn a lot about DevOps practices, tools, approaches, everything in general. So we start with the technical session by my colleague Thomas Stringer. He's principal software engineer lead at Microsoft. Then short break. Then expert from a company called Intellias, Oleksandr Karpenko, will have his lightning talk. And we finalize the event with Fireside chat, very friendly, open discussion with Dylan Beattie. And all the event duration, we expect you to be active participants. So just send your questions right after you got the one. So you heard about something that you would like to know more about or discuss, or maybe even argue if you are not agree with what we present. Just send us a comment and let's discuss. And thank you very much to those who sent their questions during the registration to the event. We carefully selected some of these questions, and definitely we will ask our dear speakers some of them, the most interesting, the most useful ones. And also during these sessions, how do we exactly gather questions from your side? Today, let's try using Slido application. This is super simple web service, and my helpers will send links, and maybe you've seen the link during the registration. So yeah, you will find the way to ask your question, and please keep them coming. Okay, now you know about agenda, and by the way, the sessions will be recorded, so you can always refer back to them. You'll find them. You'll find the link in the follow-up email, so no problem if you cannot attend part of this event. You always can watch this later, but still do not miss your opportunity to chat with the speakers. So this is the most valuable part of this event, which is completely live. So we stream live currently from multiple locations. So our speakers are distributed worldwide. Now, I'm ready to introduce our first speaker, Thomas. Hello, hello. Where are you?
Hello, how are you today?
I'm good, I'm good. How are you? Good to see you.
Great. Thank you. Same to you.
Almost in person. Yes, during this Corona days.
Yeah.
This is, let's say, new in-person meetings when you see each other on the screen. So, who is Thomas? Thomas is a ninja developer who works in Microsoft as a principal software engineering lead. And some insights about Thomas. He's a big fan of open source. He's expert in advocating of Linux, Kubernetes, and few other open source technologies. And he worked for many components of Azure, and with focusing on delivering best experience for open source products in Azure Cloud. When not at the computer, Thomas enjoys surfing the cold northern New England Ocean or snowboarding in the mountains. Yes, here I fully support you. I'm not a snowboarder, but I'm a skier, and we have
Nice.
awesome mountains here in Norway. So one day I really hope to host you here in Oslo, and let's go for skiing and snowboarding together. Okay, Thomas, what are you going to tell us about? Just give a brief intro of your session.
Yeah, absolutely. So first off, thanks for the introduction, and really happy to be here. And so today I'm going to dive into a really common but also challenging scenario, and that's delivering software through CI/CD to Azure Kubernetes Service, AKS. And I'm going to be talking about this specifically through using GitHub Actions. So I think there's a lot of great content here, a lot of really interesting technical challenges, but hopefully at the end of this session, we'll have a pretty good idea of a pretty powerful way to accomplish this.
Awesome. Then the stage is yours. Present, and let's have a quick discussion right after your presentation. Rock on.
Absolutely. I'm going to go ahead and share my screen now. Okay, hopefully you can see my monitor and my slide deck. Okay, great. I'm going to go ahead and get started then. So thanks again, everybody, for joining. During today's session, I'm going to be chatting about delivering software to Azure Kubernetes Service through GitHub Actions. Again, my name is Thomas Stringer. I'm a principal software engineering lead based out of Microsoft. And my current team, I'm working directly with the Kubernetes upstream team here at Microsoft. And we'll go ahead and get started. So here's what we're going to be talking about today. First off, we're going to just touch briefly upon why CI/CD, and then also kind of chat a little bit about why I'm going to be talking about GitHub Actions today as opposed to some other CI/CD product. And then we're going to jump into a little bit of a pipeline overview and a really common scenario, but also powerful scenario to have CI/CD deploying software to Azure Kubernetes Service. And we're also going to touch upon infrastructure as code, as that's sometimes part of your CI/CD pipelines. And then we're going to jump into the two CDs, continuous delivery and continuous deployment. Then we're going to shift the gears a little bit to some GitHub Action specific items. And we're going to chat a little bit about what a self-hosted runner is, what that means, and what it can give us. And then we're going to expand on that scenario into something more powerful and more automated and chat about auto-scaling runners themselves. And then I'm going to finish up the session here today and chat about probably one of the more important, if not the most important topics of CI/CD or any really computing infrastructure, and that's security, something that we should always be considering first and foremost. So let's go ahead and dive into this. Oops. So before we jump into this, let's chat about why CI/CD. What is this? Why do we do this? I'm not going to talk too much about this. Hopefully this crowd at this point has a pretty good idea of what CI/CD is, and we all embrace it in our daily software lives. But CI/CD is a continuous integration. And then CD, I really like to specify CD as being continuous delivery and continuous deployment. And as we chat through this next session here, we're going to start to see the differences between continuous delivery and continuous deployment. Continuous delivery is packaging your software up in some artifact, whether that's a container image, whether that's a zip file, whether that's a binary, and putting it in a place for that second CD, which is continuous deployment, to then finally deploy the software. And we do this so that we can quickly and efficiently release our software. And we can do that so we can shorten this software release lifecycle so that the delta between different releases is small and allows us to fail fast, but also understand in a small increments what could have failed. And it gives us this confidence going into production. So I think we all can understand and agree that CI/CD is a really great thing. We've been doing it for some time now, and we've got some really good motions for that. So why GitHub Actions? Why am I standing here talking to you today about GitHub Actions as opposed to another CI/CD DevOps service? GitHub Actions is a really interesting platform. First off, GitHub itself is where a lot of programmers are, right? Like we see this day in and day out. We look at software, we pull software, we use software. A lot of times GitHub is by far the first and leading place for open source software. So it really gives us this start to a platform that's being used heavily. But on top of that, GitHub Actions has been getting a lot of really great features and a lot of really great development in these past few years, to where now GitHub Action is this very modern platform that can allow us to effectively and powerfully and efficiently deliver our software to our infrastructure through CI/CD pipelines. And then on top of that, I really like the way GitHub approaches runners. And by runners, I mean the actual compute used to run your CI/CD pipelines and workflows. GitHub gives a lot of GitHub hosted runners, but they also really allow a flexible model for self-hosted runners. And we're going to be looking about that today. What exactly is a self-hosted runner and how we can utilize that. So first and foremost, this is what a typical pipeline would look like. And this is not just any pipeline. This is what a typical CI/CD pipeline would look like. From start, which is the GitHub repository, to finish, which is going to be deploying your software to your Azure Kubernetes service cluster. It is worth noting here, you can see that the continuous integration box is a little bit smaller and a little bit more grayed out. This session here today will not be focusing heavily on continuous integration. Of course, it's absolutely an important part of delivering software reliably. But what we're going to be focusing on today is the continuous delivery infrastructure as code. And then, of course, finally, the continuous deployment components here for your Kubernetes cluster. So you saw there that if the infrastructure as code box was not the beginning, but I do want to chat about this first. And the reason behind that is infrastructure as code and basically creating and maintaining your infrastructure. It's going to look different for different organizations, different teams, and different pieces of software. So in that bottom bubble there, I want you to focus on the fact that whether you put your infrastructure as code in your pipeline or outside of your pipeline, it all really depends. And the reason behind that is it's not just a management and a maintenance thing. Sometimes it's going to be a different team that's utilizing and that's setting up and maintaining the infrastructure, but also when we run our pipelines, and when you do anything, of course, on computers, there's a security context, right? So the security context that is going to be running your pipeline that we look at up in the right-hand corner there from that Git repository to that Kubernetes cluster, that's going to be running under a specific security context. And as we're going to see later in this session, we want to make sure that we're only giving that security principal the least amount of privileges that it needs. Now, by definition and the nature of infrastructure as code, especially when you're dealing with large compute such as VMs or Kubernetes or an AKS cluster, it's oftentimes going to require quite elevated permissions, of course, to be able to create a resource group, to be able to create a container registry, a Kubernetes cluster. So instead of kind of giving a single service principal these large amount of permissions, oftentimes the infrastructure as code component is going to be preceded and created by a different security principle, just so that we can exercise better security principles. Because when you're opening a PR 20 times a day, oftentimes you're not overly concerned with ensuring that your infrastructure as code is created at that moment and that there's no infrastructure drift. So that is why we're going to just chat about IAC in the beginning here. just to get that out of the way. So infrastructure as code with Azure, one of the more modern developments and features with Azure with infrastructure as code that I personally really like is what's called Bicep. For anybody that's dealt with Azure before, I'm sure we're all familiar with ARM templates. And if you've ever worked with ARM templates, you probably know the verbose nature of ARM templates. And there's a lot to them, and it almost looks like something more that computers should be working with, not so much people writing. And that's where I really think the power of Azure Bicep comes into play. It's a new language. It's a new feature from Microsoft Azure where if you look on the left-hand side there, that is what an Azure Bicep template looks like to create two very large components, an Azure container registry, as well as an AKS cluster here. So Bicep allows us to do this in a way that is really made more for the human instead of just the computer, of course, and allows us to create these Bicep templates and quickly and effectively create our infrastructure as code. And there's many other options out there, right? And we can chat about that a little bit later. But one of the really great things about Azure Bicep being developed and maintained and worked on and delivered from Azure itself is you have these day one support for the different Azure services, right? So if that Azure service is available, then you can utilize a Bicep template in this really great way. So it's a really, really fun, really powerful approach to infrastructure as code. Now, if you can draw your attention to the right-hand side there, this is going to be a theme that you're going to see me utilizing throughout this project, this demo, this session, okay? And what this is, if you've lived in the Linux world or the open source world, you're probably familiar already with makefiles. But what make does is it allows us to define different rules that we can utilize to target and do different separate, but sometimes related tasks, okay? And as we'll see here shortly, we're going to be relying heavily on this particular makefile for standardization across the product and across the community as well. Now, for the IAC component here, I have an infrastructure rule that does a couple things. It'll do a login first to make sure we're logged in. And then what it'll do is it'll do that AZ deployment group create, which is going to take that Bicep template on the left, and it's going to apply that to that resource group. Now, I'm utilizing variables just to make sure everything is consistent across, as well as able to sort of change that if I wanted to deploy to a different cluster side by side. And as I do that Bicep deployment, you can see that I pass in the cluster name parameter, which is, of course, the same variable. Once I do that, I then run an AKS update. And what that's going to do is that's going to attach the container registry, that ACR, to the Kubernetes cluster for really quick, easy, and painless interaction between the AKS cluster and grabbing those images from that container registry. One of the really great features and benefits of utilizing these Azure services. So now that we kind of chatted about IAC and sort of where it belongs and where it doesn't belong and where it could be and where it might not be, let's go back to the beginning of this pipeline. Okay, so everything always is going to start at your repository, right? In our case, we're utilizing GitHub to host our Git repositories. And what that looks like is with GitHub Actions, you define what's called a workflow. Now on the left-hand side there, you can see a workflow that I've defined. I call it deploy.yaml. And this is going to be my full end-to-end CI/CD pipeline to deploy my new software to my Kubernetes cluster. Now, if you look on the left-hand side there, you'll see that this file is nothing more than a YAML file, but it's very powerful and it explains a lot of information about what's going to happen and when it's going to happen. If you draw your attention to the first few lines there, you're going to see the on object. And let's skip that second line real quick, but you'll see that this workflow is going to run when you push a tag that matches anything. So basically, when you push a tag to your Git repository, and usually that's going to be upon a release, right? So with typical modern release management, we're creating tags and creating releases off of that. So pushing a tag is usually you're ready to release that software. So in that case, this pipeline is going to run at that point. All right, now let's draw our attention back up to that second line, what's called workflow dispatch. And this is a little bit of a cryptic word for this, but it basically allows you to manually run your workflow without having to do any other actions, right? So this is really good for a couple scenarios. First off, like what I was just doing, when I wanted to test out this pipeline, I didn't want to have to keep creating all these tags and pushing it. It can create a lot of noise, and of course it can pollute your actual repository tags. So instead of doing that type of thing, I was able to just kick off a manual invocation of this workflow job. And also, this is also helpful when there could be a time where you might want to do a deployment, say to a side-by-side Kubernetes cluster, out of band of a tag creation and push. So then in that case, you could run this workflow manually. Now, if you look below that, you'll see the jobs, which in this case is just a single job to deploy the application. And without knowing too much about the structure of GitHub Actions workflows, you should be able to look at steps and get a fairly good idea of what happens, right? We check out the repo, we build the image, we log into the container registry, push the image, get the credentials, and then finally, of course, we deploy the application to the Kubernetes cluster. Really straightforward, really great to work with. Now, if we look on the right-hand side, we're going to see a zoomed out version of that makefile rule that we were just looking at. In fact, you'll see the infrastructure rule right in the middle there. But this is what I like to use to work with the CI/CD pipeline, okay? And I would urge you, like a lot of times what you could find is that on the left-hand side there, for the workflow deployment YAML itself, sometimes you'll see some people embedding their shell commands directly in the workflow deployment YAML and configuration. I urge you to not do that for a couple of reasons. First off, if you ever wanted to duplicate that code, you're going to work with two different sources of that logic. And it's also very hard to test, very hard to develop with that. What you really should be doing is taking those CI/CD tasks and putting them in a reusable place where you can run them individually. There's typically two ways to go about that. There's shell scripts, and then there's usually makefiles. I think shell scripts work just fine, but the thing with shell scripts is there's no real standard for that. So somebody coming into the project, they might not know where the shell scripts live, they might not know what they're called, so on and so forth. That's really kind of the power of, I believe, Make is everybody typically knows where that makefile is and generally how the structure goes, right? So going into a new project, you typically don't even have to look at a makefile, and you usually know that running make build is probably going to build the software in some form or fashion. So I really think make is a great way to approach this, and as we'll see here today, that's what I'm going to be utilizing for this particular demo. And now the benefit of that is if you look back left, where you see all of the runs for each of the steps themselves, you see really nice and kind of already self-documented commands, right? Make, build. There doesn't require too much of a comment there to say it's going to build the software, build the container image. Make, push, it's going to push it, right? So I think it's a really great solution for sort of self-documenting code. So once we create this workflow, if you go back into GitHub itself, into the user interface, and if you click on actions, you'll see your workflow now exists. On the left-hand side there, you can see in this particular repo, I only have my single workflow. And once you click on that, you'll see a couple of interesting things. First off, on the right-hand side, you can see that my most recent workflow run was successful with a green check, which is really great. But take your attention to that little blue box up at the top there, and you can see this workflow has a workflow dispatch event trigger. And that was what I was talking about before, is it allows us to run this workflow manually. So now instead of having to push a tag and kind of wait for that process to happen, all I have to do is click run workflow and then select a branch. In my case, it's going to be the default main branch. And then I'm going to go ahead and kick off the workflow, and it's going to start that whole process. And once that workflow finishes to completion, you're going to have a summary like you see on the bottom there, whether or not it's successful or failed. In my case, it succeeded. And on the right-hand side, you're going to see all of those particular steps that ran. And if you think back to the deployment.yaml configuration file, the actions workflow file that we had in the last slide, you'll see a lot of the same text there, right? Build image, push image, deploy application, right? So it shows us that visual representation of that particular workflow job run. So let's take a step now into the next direction here. So we've pushed our code, and now it's time to start the delivery component here. And again, I'm breezing over and doing hand waving over continuous integration. It is worth noting that continuous integration is a very vital and important part of a full CI/CD pipeline to ensure that we're delivering code that is hopefully bug-free and won't cause regressions and that type of thing. So continuous integration is going to be that piece that runs our integration tests, end-to-end tests, and everything in between to make sure that we're delivering software in a reliable manner. But after the continuous integration component, now it's time to run the delivery, right? And if you think back to the makefile, again, I have a handful of my my makefile target or my makefile rules. And the first one we're going to run here is the build, make build, right? Which is going to do nothing more than just a Docker build and tag it with a particular image repo and whatever the version of the software is, okay? And then next, we're going to have to, of course, log into the container registry because we're going to be utilizing ephemeral single-use GitHub runners or self-hosted runners. So we're going to make sure we have to be logged into the container registry. And then finally, we're going to run make push, which is going to push that new image to the container registry. So that bottom there, it's a fairly good representation of the GitHub runner pushing that container image to the container registry. And then finally, to get your software out into the wild and into production, oftentimes you're going to see a deployment phase, right? So in this case, we're going to have the GitHub runner, which is going to run the make deploy. And what that's going to do is that's going to tell the Kubernetes cluster to go ahead and pull that new image from the container registry and utilize it and create the necessary Kubernetes resources through the manifest. Now, it's worth mentioning, if you look at the bottom there at my deploy rule, you'll see some shell tricks there, where basically I'm creating some form of variables in my Kubernetes manifest where I'm then substituting them based off of the image repo so that this is not hard coded, as well as the version, right? So we want to make sure when a version is incremented, we're telling the AKS cluster to pull the new version from the container registry. This works in very simple cases, but I do want to make a note of a tool that makes this really quite easy. It's called Helm. So with Helm allows you to handle Kubernetes resources at an extra layer up as an application, okay? So typically you're not deploying a single Kubernetes resource to a cluster. So Helm really allows us to handle that as a single application, as one single unit. And one of the big benefits of that is it allows you to have variables and different values so that you can pass it to the deployment and get a manifest from that. So it's a much nicer way, it's a much more powerful way, and it's a much more scalable way. In the case of this presentation, though, it is out of the scope of this session. But I do highly recommend that you look into Helm for these more complicated scenarios. Okay, great. So we chatted about the pipeline. So we know what this looks like from start to finish, okay? Now, whenever you're starting to work with GitHub Actions, you're most likely going to start utilizing the CI/CD pipeline with GitHub runners. And what exactly does that mean? So GitHub really, it does a great thing by allowing us to freely utilize their infrastructure and their compute to run our pipelines, okay? And that's really great, especially for smaller projects or for just starting out, to just kind of get that green check for your software deployment. But one of the more important and more powerful components is being able to host the runners yourself. So that's what we mean by self-hosted runners. In the case for Azure customers, and which is what we're going to be talking about for the rest of this session here, what that looks like is hosting these runners for your CI/CD pipeline in your own Azure subscription, okay? And there's a couple of advantages. There's also some disadvantages here to this as well. But being able to host these runners yourself, you control the infrastructure, right? So this is a really large piece of security and ensuring that your code and your pipeline runs within your walls of responsibility, okay? So when you have people say to you, well, where did this code just run? Sometimes it's not the right answer to say in somebody else's VM that I don't have access to, right? So being able to control the infrastructure really gives you lots of power, really gives you lots of security, and it gives you lots of ability to manage the environment itself. The other really big benefit of utilizing self-hosted runners is now you can and you should utilize a custom runner image, okay? And let me tell you why that's really important, because whenever you're utilizing GitHub hosted runners, you're going to be utilizing a fairly generic image, right? So whenever your pipeline has to do something that is not included with that image, now your pipeline needs to handle those dependencies, right? Let's say that GitHub hosted runner image doesn't have kubectl, okay? Well, part of your pipeline now is going to have to be to go fetch those dependencies and install them on the runner before it can actually do its work. Otherwise, you're going to have a failure. So being able to create a base image for your self-hosted runners, now you can include those dependencies directly in that image. And that gives you a lot of power, and that also gives you a lot of speed and efficiency, right? Now, because you're not having to pull these big dependencies into the runners themselves as they're trying to do their work, right? So that image on the left-hand side there, that kind of shows the process and the workflow, okay? So typically you would have a base image VM, basically just a VM that you stand up, you install your dependencies, including the GitHub Actions process and workflow. And then what you would typically do is you would create an image from that VM. And there's a couple of ways to store that image and utilize that image. I personally really like to utilize shared image galleries. It allows you to very efficiently and effectively version your images themselves, as well as share them across your organization. And then we'll see what that process looks like, but then you can create your ephemeral GitHub self-hosted runners by pulling those images, okay? And typically, what I like to do, and what we're going to see here soon, if you look in the corner, you're going to see a little tag on that VM called cycle equals delete. I like to create a process into these VMs themselves so that when they're done with their work and done with that GitHub Actions workflow job, they can do some cleanup on themselves, right? Because that's going to take us to one of the disadvantages. But another advantage that you get with utilizing self-hosted runners is a very important security piece here by being able to utilize Azure managed identities. Okay. Now, when you use GitHub hosted runners, typically you're going to be utilizing a service principal to access your Azure resources in your Azure subscription to deploy your software or deliver those images. And when you're working with service principals in Azure, you're passing around a secret, right? You're passing around that service principal secret. The benefit of utilizing Azure managed identities is you no longer have to deal with the security implications or the overhead of passing around that secret. Managed identities are that out of the box, highly secure, very easy to work with security principles. So that's one of the big benefits, in my opinion, of utilizing self-hosted runners is now all of a sudden you have the ability to use these managed identities to access the Azure resources in your subscription. So much like everything else in life, there is also some disadvantages to having your self-hosted runners too. Like we talked about, one of the benefits is you run your own compute. Well, one of the disadvantages, of course, you're going to be paying for that, right? Now, I'm going to show you some strategies here to minimize that cost, but at the end of the day, creating resources and running VMs in Azure is not going to be free. Another one is you must manage the images and the runners themselves. This is kind of an obvious thing, but when something doesn't work, it's up to you to troubleshoot that, right? As opposed to utilizing a GitHub hosted runner where those images and those VMs are managed by somebody else. So when something's broken for your CI/CD pipeline because of a runner, now you're the one troubleshooting it. All in all, I think the advantages very far outweigh the disadvantages for many scenarios. So now we talked about self-hosted runners. What does this actually look like? How do you actually create a self-hosted runner? So what I'm going to step through here is creating a single self-hosted runner in a non-automated way, okay? And I think it's worth understanding how this process works. So if you were to go into your repository, click settings, if you were to click actions and go into the runners, you'll initially see in a repository that there's no runners configured. And if you wanted to manually create a self-hosted runner, you could click that new self-hosted runner up at the top. What that does is it brings you to another window. In my case, I selected Linux because I'm always utilizing Linux as my workload. And GitHub does really cool things. They give you all of the shell commands that it takes to get this machine configured and running to be a runner. So these actions really help you get to that point where this VM is now able to take this workflow and do some work. As you can see in the bubble on the right-hand side there, originally we also talked about creating a base image for your GitHub self-hosted runners. You would be putting this logic into the VM itself, right? So you wouldn't have to do this every time the VM started, ideally. These bits would just be living in that image, so these VMs are designed to be GitHub runners from boot up. So once you do that, and you set up your runner and you run those commands, you'll notice that in the runners part of the repository, you're going to see your new GitHub runner showing up, okay? And I just want you to focus really quickly on the labels right there. You can see I highlighted self-hosted, and there's also other labels like Linux and x64. Now, the way we tell our workflow to utilize our self-hosted runner, which is a built-in label, we can specify the runs on in our workflow YAML, okay? And this is a default label for self-hosted runners. For organizations that have different types of runners for different pieces of software or projects, this is where you can have custom labels so that a particular workflow is only going to run a particular subset of runner VMs. Really powerful stuff. So we just chatted about a scenario where you're creating the single GitHub host, or the single self-hosted runner, but that is not typically what you're going to see, nor is that scalable, right? Like what that would look like is somebody would have to create a release and make a phone call and ask somebody to stand up a VM. That's not what we're looking for. We're looking to automate this whole process from start to finish. So how do we do that? We utilize webhooks. And GitHub allows us to define a webhook so that when you do an action, or when the GitHub Actions does something with the workflow, it makes an HTTP post to a webhook. Now, in my case, what I did was to do this in my Azure subscription, I created an Azure Logic app with an HTTP request trigger. So what that does is that handles the webhook request payload that GitHub sends when an action is meant to run. And what that's going to do is it's going to look at the payload, and it's going to make sure that the payload includes that this GitHub workflow is for a start and not a completion, not a cancellation or anything like that. And then once this logic app determines that, hey, this workflow wants to run, it's going to run an Azure Automation runbook. In my case, I created an Azure Automation Python runbook. And all this does is this creates the VM from the self-hosted runner image to be able to handle this workflow. So this Azure Automation runbook now runs, and it's going to create that self-hosted runner. And when that self-hosted runner VM is provisioned and running, it's going to take that workflow job that was used to initially start this whole process. And another thing I like to do, like I mentioned earlier, is I like to have these images and these VMs kind of programmed to handle themselves whenever they're done with their work, right? Because at the end of the day, we just stood up and started a VM. If we leave that running, even after the completion of the job, we're most likely consuming money because it continues to be run. So I like to have some hooks into the VM where once it's done doing its work, it'll automatically deallocate itself, or in some cases, be able to delete itself. So let's see what that looks like. So this is an end-to-end of what it looks like when you have this automated self-hosted runner. So at first you see there's absolutely no runners. And in this case, and in this scenario, you are not going to be clicking that new self-hosted runner. But what you're going to do is you're going to kick off a new workflow like you see on the bottom right-hand corner. And what's going to happen is that Logic app is going to get the HTTP request, the HTTP post from GitHub that an action has done something. And you'll see the trigger history. In my case, you'll see that it's exceeded, and it's going to run that Logic app, which in that case is going to look at the payload, and it's going to see that somebody requested that a workflow starts. And once it does that, it's going to start an Azure Automation runbook. Again, mine's Python. And what that's going to do is just going to create the VM. And once that VM is created, you'll notice that in your runners, it's automatically going to be shown. Okay, in this case, you're going to see that it's active because it's got stood up to actually take a piece of work. So it's going to start working that GitHub workflow job. And as you can see on the bottom there, that's just a little bit of output from AZVM list to show you that 5746 is now up and running. And you can see some artifacts of some previous runs that I did of VMs that were automatically deallocated. So now once that VM is done running, right, this is just an ephemeral runner. So after it does its single job, it unregisters itself with GitHub. So you see that it no longer is configured to be a runner. And also, like I mentioned before, I like to program the VMs to deallocate themselves to minimize dramatically how much these cost. So as you can see on the bottom there, that automatically this VM has been deallocated. So this is a really end-to-end, very robust solution to be able to automatically create and deallocate these GitHub runners that are hosted in your own Azure subscription. The final piece that I want to talk about here today is a very important one, is security, right? We want to make sure that, especially with our CI/CD pipelines, we're exercising the principle of least privilege, okay? And what that means is we want to make sure we're giving our CI/CD pipeline the least amount of permissions that it needs to do its job, right? So in this case, and in this typical pipeline, there's very few things that this particular managed identity needs to be able to do. It needs to be able to push an image to the container registry, get some credentials for the cluster, and then, of course, read the AKS clusters themselves. So what I would do is I would create this custom role that you can see on the left there, and then I would apply this role to the managed identity at the scope of only the resource group that was created that will host all this. So now we have a very contained and very secure environment for our CI/CD pipeline. I do want to make a quick note. It is very much out of the scope of this session, but on the bottom right-hand corner, I do make a note that the GitHub Actions process that's running on this Linux VM, we also want to make sure that security principle, that Linux user that it's running under has very few privileges, right? We don't want to run GitHub Actions as root. We want to make sure it's running a very limited service user on the Linux VM itself. So we talked about a lot about here today. We chatted about first why GitHub Actions, why CI/CD. I showed a very powerful but common pipeline. We chatted a little bit through about infrastructure as code, and we talked about the two CDs, continuous delivery and deployment. And then we talked a little bit about how runners and the infrastructure works for the pipelines themselves, as well as how to auto-scale these pipelines for a very production environment-ready solution here. Then we finalized it with talking about the security, which is a very important aspect that we should always be considering, and that is no different with our CI/CD pipelines. So I just want to thank you for your attention. Again, my name is Thomas Stringer. That first link there, it's my website, which is pretty much just my blog, trstringer.com. Check it out if you're looking for very similar content, and please feel free to follow me on LinkedIn, as well as check out my GitHub account. So thank you very much for your time, and I'll pass the microphone back to you, Maxim.
Yeah, thanks, Thomas, for this really end-to-end journey on Azure CI/CD and GitHub Actions, full of technical details, exactly what our dear participants love to watch. And we have few questions sent by folks during registration, and I see that we received few questions now while you delivered your session, and many of them are about one particular thing. To generalize this, let me ask you something like this: Azure DevOps versus GitHub Actions. What's your opinion? What's your message on that?
Yeah, absolutely. That's actually a question that you see coming up a lot, and I'm going to preface this by saying I am very much like everybody else. I'm just a user of GitHub Actions and Azure DevOps as well. So I don't have any real information on the roadmap or kind of what the plan is in the future. But I can say that there's lots of really great active development on both platforms and both products. And I can say that there's a lot of investment in GitHub Actions, and that's one of the things that I really like is it's this nice, really modern approach to CI/CD pipeline. So I wish I could give some really good information of what the future looks like for both of these platforms, but unfortunately, I'm also just looking from the outside as well. So hopefully that answers. Not a great answer, but unfortunately, I don't have much more information.
Yeah, fair enough. Fair enough. Thanks for your vision on that. Now, more concrete and very practical questions. So we have pipelines that we can set up in multiple ways, YAML or classic. So, what advantage do you see in YAML organizing of pipelines versus the classical what you get one?
Yeah, that's a really great question. And especially as, with Azure DevOps, we saw this kind of, sort of transition into these YAML pipelines. But what it really boils down to is the real power of many things, especially CI/CD, is I really like to consider it as everything is code, right? If ever I find myself pointing and clicking, I'm always asking myself, could this be represented as code? Could this be some template, some declarative or even imperative code that I can do a couple of things with? First off, the everything is code approach is really benefited with being able to version it, right? So by going, having your pipeline as well as your infrastructure as code, right? The same thing applies here. Having these artifacts kind of, mature with the software code base itself, what it does is it really does a nice tight coupling between these things that are so very dependent on each other, right? So by having our pipelines in YAML, that really allows us to keep it versioned, and one of the other big benefits of that is the ability to kind of share it and reproduce it, right? We're used to the days where somebody would send us a bunch of screenshots about pointing and clicking and doing something in some graphical user interface. But I think we're really moving away from that. And pipelines kind of have showed us that being able to version control this and being able to share it with code and configuration, it's really much more powerful, much more user friendly than kind of the classic pipelines of pointing and clicking. So hopefully that answers the question.
Yeah, that's a very good answer. And actually, personally, talking about myself, it took some time for me to understand how YAML pipelines work exactly. But now, after I got the basics, the essentials of this configuration, I definitely don't want to return to this point and click configuration. So that. I believe the future is for YAML. Then, Thomas, thank you very much for your session and for answering the questions. Let's stay connected. We'll send information how to contact you to our dear participants on follow-up email. On that, have a great day. In your time zone, I believe it's day, right?
It's still early. Yeah, still early. So thank you very much for having me. I really enjoyed my time, and I hope you have a great day.
Absolutely. Thank you. Bye-bye. Okay, so cloud builders, what's next? Next, we have really short breaks, maybe 3 minutes, just to refill our cups. And then we continue with our program. Next speaker will be Oleksandr, but I will introduce him right after the break. See you in 3 minutes. And we are back on track. Are you ready, folks, to get more knowledge, more skills from our next speaker? And next speaker is Oleksandr Karpenko. He's a senior DevOps engineer at Intellias. Some facts about Oleksandr. Over 5 years of commercial DevOps and SRE experience, over 7 years of engineering, and successful setups of CI/CD releases on security applications, web marketing, portable, desktop, and mobile apps. Oleksandr is quite experienced in DevOps, what I can say. Just for your information, folks, this session is pre-recorded, so we will turn on the video right after my intro. But please still drop your questions to Slido. We will pass your questions to Oleksandr, and he will answer every single questions you send in the follow-up email. Now, let's watch Oleksandr's presentation.
Hi there, my name is Oleksandr and I created some presentation for you. It's called Azure Policy plus Terraform equal policy as code. Quickly overview on topics that we have. Overview, Azure Policy, Terraform, Azure DevOps, Policy as Code workshop. On each topics I will show you best practices on how to use it. In few sentences about me. My name is Oleksandr Karpenko. I'm working in role senior DevOps engineer at Intellias. Overall 7+ years experience in commercial engineering. Successfully set up different CI/CD releases on different projects. Quick overview: what is policy code? Policy as code. Policy as code. It's quickly. It's pretty similar to infrastructure as a code, but you don't manage all of resources in provisioning or some changes. You only resource policies that you set on your infrastructure, on your resources, on your applications. It's the idea of writing code in high-level language to manage and automate policies. It helps you to automate a lot of operation job and not only automate and prevent any issues, error, or failed resources by already accepted policies. This slide will show you a few ways how to manage policies, how to operate them. This slide will show you best practices from Azure for Azure policies. So first of all, we will create policy definition or create initiative definition. So it's two ways to create policy itself. After we need to test it, we don't need to apply enforcement mode or to do some actions before we did not check that all will we will not broke resources, that any resources will not get any new issues or some changes. And after we sure about our policy, we can grant MSI permission to do any remediation or update assignments for enforcement mode to enable it. I will not saying a lot about Terraform and Azure DevOps because a lot of people already know what is infrastructure as a code, what is DevOps itself. And I will only show you best practices on it. First of all, I will start from my Docker file. As example, this Docker file and Docker image itself I am using for our Docker infrastructure. It will contain itself Terraform and Tflint. Tflint, as you see, we download it, unzipped it, so we have it. And you can check my pipeline where I use this. And this pipeline has different steps. First of all, you need to init your template. And I choose to show only not initialization of Terraform, but check format. Maybe some people don't use it on their projects. So we will check directories, and inside directories, we will check difference between Terraform formatted template and our templates if it's not formatted yet, and show this difference on output. If some difference will show in output, this pipeline will stop with error, and people will know that we need to do some changes, and after this pipeline will run small. We do some validation where we apply Terraform lint. It helps us to check our templates before we apply command plan or apply stage. That you used command apply. This will save a lot of time for us because command plan and command apply for huge infrastructure with different templates with few modules will runs for few minutes, maybe more than 10 minutes, and Tflint will show you less than 30 seconds if you have some issues. After easiest plan and after apply with after approve. So that's it. Your infrastructure now is good for apply Terraform and manage Terraform in way of infrastructure as a code or in way of policy as a code. So if on example on my pipeline, this will have few stages for. But we can separate format stage with initialization stage, format stage, after next stage validate, plan, apply, and we also add some few new steps dependent on our policies or our project's rules. So what is policy itself? Policy itself have already built-in policies by Microsoft. It helps you to enable something, to enable monitoring, to enabling some data for collecting, to deploy something if it's not deployed. You can check by your own a lot of built-in policy, a lot of collection of built-in policy, and it's really good things to use in way to manage your infrastructure. It will save a lot of operation job from manual job to fully automated. As example, I show you as example our previous speaker said you about Kubernetes best practices, and I will show you how to, as example, use policy as a code on Kubernetes. We will create some Kubernetes service, and our policy will apply it for it. So I already set it up few policies for naming convention. All of projects need to use naming convention because it will be a mess in the infrastructure and resources. So you see, Kubernetes or Azure said me that all fine and I can proceed with my setup. So I will run it validation, and on this step, Azure will check all applied pipeline, all applied policies, and we'll see that yes, we really have some policies where resource test one policy AKS cannot be deployed. We can open this policy. As example, it's it, but I will open once more for you. What we have in this policy? We check for some name convention. As you see, we have applied in for some scope, assignment ID. I will show you in templates what is assignment ID applied for. And we have parameters, name pattern. So name pattern we use for naming convention. As example, we have some pack proof of policy as code dash question mark for letter and another mark for numbers. And you see this naming convention not matched our convention. If we want to matching it, we need to create the same as we provided in our name convention. So Azure infrastructure will not give you to create something not applied by policy, by policy rules. And how I did it? So I created code. I created policy definition itself, where I describe my policy rule. If all of not matching our name pattern in type Microsoft Container Service Manager clusters, it's Kubernetes, then deny, effect deny. We describe also parameter and create assignments for few resources. It can be a resource group, it can be one resource, it can be subscriptions. I use subscriptions so it applied for all resources in these subscriptions. And also some name pattern, value for name pattern. This value, if you change in template, you will change it on your infrastructure. But if some resources already provisioned and deployed, it will not destroy them. It will only show that some resources did not match to name convention. So if we will create some when I show you some remediation task, you can create some deployment if not exists. So as example, we can create some job that if some resources will not match our name pattern, we will destroy all resources and deploy new resources. So I think it's really good job for DevOps. It's really automated and you don't need to do all of things by your hand manually. So I think that's it. Also, I have another pipelines and another best practices that I want to show you, and we will have separated webinar on the Russian language where I will show you this and another policies in use. Thank you for your attention. Take care and have a good day.
Thank you very much, Oleksandr, for such a practical and useful session. Very nice amount of information compressed into just 11 minutes. And I'm sure folks have many questions, and we'll send all the questions to you so you answer them by email. What's next? Next, we have to say thank you very much to our dear sponsor company, which is supporting this event, I believe, from the very beginning. Company called Intellias. This is actually a place where Oleksandr works. So what is Intellias? Intellias is one of the biggest IT companies in Ukraine, ranked among the best IT employers by Forbes and DOU. And it's not a big surprise because human attitude is what Intellias stands for. Now you have opportunity to join Intellias team very, very quickly. They are hiring, and on October 23, Intellias is holding DevOps Hiring Day. This is opportunity for you to choose a project, get an offer, and welcome bonus on the same day. And no doubts, today's event is a good helper for you folks to refresh your knowledge about DevOps, maybe to grab some new knowledge. So use this opportunity. Now we are absolutely ready to invite our participant of the Fireside chat. Let me introduce our guest from UK, Dylan Beattie. Dylan, hello.
Hey Max, how are you?
I'm good. How are you?
Yeah, good to be here. How's it all going? I caught a couple of the sessions
What's
there.
the weather in
Looks like
What's the weather in UK these days?
It's all right actually. It's surprisingly warm for this time of year. I
Yeah,
remember
same in Norway.
I was in Kiev a couple of years ago in Ukraine, where I think some of the event is coming from today. And someone said the weather's great. It's sunny for 5 months, then it rains for 2 weeks, then it freezes for 5 months, then it rains for 2 weeks. And I thought, all right, that sounds nicely predictable. This is London. Anything goes, So
Yep. So let me briefly introduce you. So what I have on my notes, Dylan is a systems architect, developer, and director of Ursatile, independent consultancy based in London. And some facts about you, Dylan. You are Microsoft MVP. And by the way, I was Microsoft MVP also before Microsoft hired me. And in Ursatile, Dylan helps our organization bridge the knowledge gap between software development and business strategy. Dylan has been building data-driven web apps since the 90s of last century. In that sense, we are also soulmates. I also started to build my web experiences at the same time. And expert in managing teams, workshops, and everything from tiny standalone websites to complex distributed systems. So these are just facts. Now, interesting facts. Dylan is a rock star. He created the Rockstar programming language and performed his software-themed parodies of classic rock songs all over the world as Dylan Beattie and Line Breakers. And you see, I
the
also
thing
do
you gotta
some,
realize, Max.
some music stuff, mainly as electronic sound producer and hobbyist DJ. Now, I think our dear participants built full picture of what to expect from you. Now let's break all these expectations. Let's have something really friendly, funny, and open.
Cool.
Okay, so I did this formal introduction of you. Now I want to hear something about you from yourself. So please tell something about yourself, and also connect this to DevOps. What's your relation to our today's topic?
Cool. So probably the thing that is interesting there is I like a lot of people, I started out as programming home computers in the 1980s when I was a kid in Amstrad Basic was my first programming language, and then Logo. And I got into building websites very, very early. Like I wrote my first web page in 1992, less than a year after HTML and HTTP 1.0 were published. And, it was kind of strange because there wasn't very much on the web at that point. It was something that kind of universities and labs used to publish their research and things. But, the whole kind of the boom in the web, that took a little while to get going. And then by the late 90s, I was building websites for, companies, and building intranet applications, starting to figure out how to use Microsoft Classic ASP and a VB script, which was what everyone seemed to do back then, to build websites that ran off databases and that kind of stuff. And the interesting thing I think about DevOps, because I've been working in IT ever since, and I used to be a webmaster back when that was a job title people had. And when the web was first kind of emerging in the late 90s, the early 2000s, there were a lot of companies out there who were like, they have IT, they have Microsoft Windows NT servers, and they have email and, Novell or Lotus Notes or GroupWise, all these kinds of things. And that was corporate IT. That was the enterprise IT. And corporate IT didn't want anything to do with websites because they thought it was, something for marketing and stuff. So quite often, when you were hired to build a website, the company would be like, "Oh, you didn't do everything. We don't want that anywhere near our servers. You run it." And so, the process of setting up websites, you would, set up, install servers, you'd configure things, install patches, you'd make databases, create data schemas. I used to make network cable. Like I would have weeks when one day I would be using Photoshop and Macromedia Fireworks to make buttons. And then a couple of days later, I would literally be crimping network cable to connect servers to switches in a rack in a data center so that the server that was hosting the website that had the buttons on it could go live. And so we could, set that up and, we'd run backups, we'd run recovery and data security and all this kind of stuff. And so, the sort of the whole DevOps culture, the idea of the developers also, are involved in operations, and you have operational concerns being considered from the very start of the development process. To me, it was kind of a surprise when I discovered that there were companies that didn't do that. And so, having come through this very interesting journey of being like, okay, all right, I've done HTML. What next? Oh, database. Okay, how do we do databases? We do that. All right, now it needs to go live. What's DNS? Okay, that's DNS. Okay, now what do we need? What's Border Gateway Protocol? Oh, all right, that's somebody else's problem. Don't worry about that. And so, my perspective on software development as a profession, as opposed to a hobby, has always been, if you're building a service that people are paying for, you need to understand the whole thing, because that's, to some extent, that's your responsibility. And you need to, if it goes wrong in production, you need to be able to figure out what happened. And if you encounter something unusual in development, then you need to be able to think, well, hang on, works on my machine, but when this goes live, is this something that I think is going to cause problems? And that's a journey. That's something that you keep learning more and more about as life goes on. And yeah, so that's kind of a bit about me, where I came from. And, the last 20 years, I've gone from building little websites to building big websites to building big websites that use message queues to push stuff into, cloud service providers with Redis caches and gRPC and all this kind of stuff. But that kind of sensibility of, I want to understand what the system looks like to a developer and also how it's going to behave in production. I think that's the heart of kind of a DevOps mindset for me.
Awesome. Thanks for sharing your journey. And webmaster, nowadays it's almost forgotten word, right? We are web content developers now. Webmaster, it's something from late 90s, maybe early 2000s.
Well, we had this phrase, full stack developer. And I'm like, unless you can do Photoshop on Monday and make network cables on Tuesday, you're not a full stack developer. Like, those are the two extremes of full stack development for me, so.
That's true. Yeah, so no doubts. Lots of developers are watching us right now. Web developers, web backend developers, web front-end developers. And maybe if some of them, few of them, many of them think, hey, maybe I should check DevOps as a profession after what Dylan presented. Like I understand how things work. Maybe if I have a larger picture on full end-to-end journey from my code to globally distributed web solution somewhere. So what can we maybe advise to these folks, and maybe let's even do step back. What do you think is DevOps a role, like mindset, a profession? So how does it look in current ecosystem of development in general?
So I think the best way, certainly the way that it makes sense to me to think about it, is you think about like a football team, like a soccer team. And you imagine you have a football team who they're not in good shape. You know, there's people that they haven't been training, they've got overweight, they're smoking too much. And somebody says, oh, we need, football teams should be athletes. And so they hire some athletes and they add them to the team. And it's like, well, okay, now we have a couple of people on that team who do actually know what they're doing when they go out onto a football field. But that doesn't mean that the whole team is going to start winning games. And, I think of DevOps as being, it's something that done well. It's like being athletes. Everybody on a soccer team should be an athlete. They should all be in shape. They should all kind of be responsible for, being in a physical condition to do that thing well. And so, when people think about, is DevOps a profession? Certainly, I think organizations who are trying to embrace DevOps as a culture, they need help from people who understand it and understand its potential, who've seen it done well. But I also, I sometimes see the thing where a company's like, oh, well, this is the development team, and then upstairs is the operations team, and then over in the next building, that's the DevOps team. And you're like, well, how can you have a DevOps team if you've also got development and operations? What is DevOps doing? Because, if the developers aren't doing DevOps and the operations aren't doing DevOps, then the company is not doing DevOps, even if they have DevOps people, because you still, that sensibility of, sort of an awareness of the relationship between development and deployment and production and maintenance and all these kinds of things, that's always going to be missing. And so, I think it's companies go out, they look for people with DevOps experience or DevOps engineers. And I think, sometimes they do that for the right reasons, because they're like, we need to start breaking down some of these barriers that exist between the different teams in our organization. And we want somebody with experience to help us do that. But, the other extreme is the organizations who are like, the developers don't want to touch production because they're afraid of it, and operations don't want to get involved in development because that's not their job. So we're going to add a DevOps team, and we think that's going to help. And that's where I see, I think if you're a good engineer who understands the whole DevOps lifecycle, and you find yourself working in an organization where you are struggling to make those kinds of changes happen, maybe take a look around and be like, we got DevOps, cool, but if we also have Dev and we also have Ops, what are we going to do about it? And some organizations that I've talked to and heard about are like, no, we're not changing that. No, you do DevOps over here. And I think that the great maxim in IT is that experience is what you get when you don't get what you want. And if you find yourself in that situation, learn as much as you can, but be prepared for the fact that really to use your skills and your experience to actually make things better, maybe you're going to need to either get a promotion so you have authority to start moving things around, or you're going to need to go and find somewhere else to put your skills to use,
Yeah. So it sounds like DevOps is a joint responsibility, right? And successful companies, they have teams where every team member at least understands, right, the value of DevOps and how to perform their job in the most DevOps friendly way. Sounds like this. Yeah. Cool. If still some folks want to go and dive deeper and fully specialize on DevOps, so doing nothing but purely DevOps, so DevOps professionals, DevOps engineers, what do you think? What kind of backgrounds, like technical backgrounds, or maybe not even like too technical backgrounds, these folks should have to really succeed in their DevOps journey?
I don't think background is as important as attitude. I think it's very, very much about, take everything that you've learned. Some people I know who, have developed a very good DevOps sensibility. They started out as database administrators. Some were security engineers. Some of them were system admins. Some were, coders, programmers, front end, back end, that kind of thing. But what I see in the people who I think can make the biggest difference is a curiosity that, okay, I want to understand, there's developers who are like, yep, I've checked in all my tickets, I'm going home now. And there's developers who are like, no, I want to see what happens when my code goes live. I want to understand, what is it that what are the incidents that are never going to happen in isolation? And, I think it's that kind of curiosity, and that can come from anywhere. It can be a, developer. There's a classic, I think a very demonstrative example of this, which is transaction deadlocks in SQL databases. Because a transaction deadlock to me is a classic example of a problem that never happens when a developer is running code on their own machine. Because it is very, very difficult to create the kind of simulated load testing environment that will lead to transaction deadlocks on localhost. And so a lot of developers have never seen a transaction deadlock. To the earlier part of their career, they've got, websites and JavaScript talking to, MySQL or Postgres or SQL Server. They got all this stuff going and it's brilliant, and they've load tested it and it's fast and they put it live. And then as the kind of traffic in the real world sort of scales up, things start to fail. And think about a transaction deadlock. The other one is that most of the time, somebody on the other end, your user, is going to get a 500 internal server error, and they're going to go, what? And they're going to hit refresh and it'll work. So it's not a reproducible bug. It's a very, very difficult thing to isolate and track down and figure out where did it come from and what caused it. And so the only way that you, as a DevOps person, whatever, can develop a deep understanding of transaction deadlocks is if you understand the way the code was written and you understand what happens when it's running in a production environment with thousands of people hitting it simultaneously. And, a lot of the conventional kind of siloed approach to IT, even if a bug gets filed, the developers are going to be like, well, we couldn't reproduce it. And it's like, well, did you try hitting it with 1,000 requests a second? And the developer's like, how do we do that? I'm working on a laptop here. But then you get the person, either you get the developer who's like, hey, what's the code? Oh, what are these errors? Developers can see logs, or they can see app insights, or if you got something like, Datadog or one of the, application monitoring platforms, even just something like Logstash, developers can see it. They're like, hang on, a 500 server error. We didn't have those on dev. What's going on? And they start digging into it. Or sometimes it's the other side. Sometimes it's somebody who kind of works on the production, systems admin or site reliability engineering, who takes those logs and goes back to a developer and says, hey, check these out. We're getting this server error. And the developer's like, that's funny. What's this? Oh, transaction deadlock. And then they're like, okay, where's the deadlock coming from? And when you get those two people sat down at a workstation, and one of them's going, no, look at the logs, and the other one is trying to simulate that in a local, like a development environment, I think that's when you really know it started to click. Because at that point, you have the development side is bringing the background there is understanding how to write code, how to build systems and test them and deploy them. And the other side is understanding what happens in the wild and logs and latency and all these kinds of things. And, you take the wall down and those people start having a conversation, and both of them, I think, are then on their way to embracing the idea of DevOps as a profession, perhaps. But, as I said before, I think you can be a DevOps engineer, but DevOps done properly is something that needs to be embraced across the organization you're working in. I don't think it's possible to succeed if you're the only one doing DevOps and everyone else is doing something different.
That's absolutely true. If you look at one of the definitions of DevOps, I believe this one was given by my colleague Donovan Brown from Microsoft. So DevOps is a union of three things: people, process and products to enable continuous
Yep.
delivery of value to our end users. And people is something that on the first place in this definition. And you mentioned a very important thing, a very important point, like when two people sat together, magic happens, right? Maybe not on the technical level. So, but by the way, I really love the level of our discussion. After two very deep technical sessions with code samples, with configuration samples, I think that's really awesome that we talk about, let's say, more people side of the story, maybe to inspire more people to go to explore DevOps, to be curious about DevOps, and who knows, maybe they will become awesome DevOps professionals. If we go back to this conversation about background, about profession, and taking into account this people side of DevOps as a profession, what do you think? What's your opinion on skills needed for being successful DevOps engineer, and maybe not only hard skills but soft skills? So how what do you say about this, and maybe some recommendations and advice to our dear attendees?
So the first thing I'm going to say is that I hate the term soft skills because it implies that they're easy, because hard means difficult, right? And it actually turns out that the hard skills are the things that you can learn by yourself. You can sit at home and you can sit, writing code, reading books, reading tutorials and blog posts. And, those things, it's actually, they call them hard skills, but it's easy to get good at them because you can practice them in private when no one sees you. And then by the time, even when you're writing code, the compiler tells you made a mistake. You don't need to show anybody else. But what some people call the soft skills, I prefer to call them, core skills, is about, communication and that kind of stuff, management, collaborating well with people. That stuff's really, really difficult, because the only way to get better at it is to do it in public with other people where they can see you fail. And, that when you first start out, you're going to make mistakes, and other people are going to, A, they're going to see that you've made mistakes, and B, they could potentially have, consequences that you're going to need to live with. And so people who've been through that process for a good chunk of their career develop a sort of, I think, a way of looking at problems that you don't get when the only thing you're doing is writing code. I love writing code. I love programming and the activity of sitting by yourself and going, right, implement this, implement that. But really to build systems that work well and, solve real problems, that involves collaboration, and collaboration involves a whole bunch of skills that you're never going to be able to learn if you're just sitting. I was going to say when you're just sitting at a keyboard, but so much of communication now happens asynchronously online and stuff. But I think, the fundamental skill is curiosity and a willingness to explore, other people as a resource that you can, sorry, I hate the word resource there, a willingness to start conversations that'll help you understand the problem better. And, that's whether you're coming at this from, like I said, a technical, a development perspective, or a product ownership perspective or something. One, I think there's that thing, if it's a computer, if we dig deep enough, we will find out why it did what it did. And that's something, when I was a kid, no one ever told me what computers couldn't do. And so I spent a good couple of years convinced that you could get like high definition color graphics on an Amstrad 128 if you just knew how. And then it was like, oh no, actually, hang on. No, we can't do that yet. But, I think a part of it is that mindset of, well, nobody told me this was impossible, so I'm going to keep digging. I'm going to keep seeing what I can learn, what I can discover. And, like I said, another part of it is willingness to start conversations and involve other people in that journey. And hopefully, you learn something from them, they learn something from you, and between the two of you, or between the group of you, you end up producing something which none of you would have been able to produce working on your own. And when that happens, I think that's pretty special.
Awesome, awesome. Yeah. Again, word curiosity. I think that we mentioned this multiple times, and this is super important for pretty much every IT profession. I personally learn something new every single day, and otherwise you'll just fail as a professional with the current pace of how technologies develop. Well, yeah, literally every day you have to learn something new.
Yeah.
Cool. If we talk about the projects you build, maybe your personal projects, maybe projects for your customers, clients, could you describe maybe some DevOps configurations you have on those projects created by you or your team, something that you can share as best practices, as a recommendation, and please choose any level, going deeper into technical details or in more conceptual level, something practical that you can share.
So probably the single most kind of impactful thing that I've ever been involved in was a company I worked at a few years ago. Well, I'd been there a long while. Like I joined them when we were doing classic ASP and JScript, and by the time I left, we had a team of about 15 people doing, DevOps with .NET and microservices and CRM integrations. And we had a project there. We wanted to take a lot of the risk and uncertainty out of deploying to production. And what we did was we moved everything to from on-premise to private cloud, and then eventually to AWS, Amazon Web Services. And we eventually got to a point where our staging environment would be built from code every night, and then we would restore the production database backups into staging every morning at about 6 a.m. And we then had to go through when GDPR came in, do a whole bunch of work to make sure that we weren't using any sensitive customer information in a staging environment, which is another big sort of consideration that is becoming quite difficult to manage. But what that meant is that you could. We were doing something that might have been risky. You had a replica of production where you could run the deployment. You could build it. We were using TeamCity. We were using Octopus Deploy. So TeamCity was the build server that created NuGet packages. Octopus Deploy managed all the configuration variables and deployed the right things onto the right servers in the right order. We're using ReadyRoll to manage database migrations. And, that finally got to a point where, they say never deploy on a Friday. And it almost got to a point where it's like, well, we pushed it to staging on Friday morning and nothing went wrong. We could push to production on a Friday afternoon and no one's going to worry about it, because we were that confident that, if something deployed to staging and it was clean and everything was green when we were finished, then it was going to do exactly the same thing when it went live. And that's always been one of the biggest headaches of any system. Just literally this afternoon, I was troubleshooting some entity framework migrations where it turned out that the EF core was defaulting to the wrong collation. And this had never kind of come up before until settings started going around. I'm like, okay, but the production databases, they'd been running the correct collation the whole time. It's just the entity framework didn't know that. And so when you fix it, entity framework is then like, oh, yeah, well, now I'm going to try and override the database collation. And of course it can't, because one, you're supposed to set that before you create any columns in any tables. And two, it's already been done. It was done months ago. That's a great example of something that it's like, I need a replica of production where I can test this migration right now and see what it's going to do on, oh, that's bad. I'm very, very glad that didn't go live. And so I think that is, for me, the thing that teams should aspire to is you got to think, what are all the things in production that don't exist anywhere else? And, sometimes it's just having a reasonable sized replica set of data you can use for local development and staging. Sometimes it's about stubbing web services. Like I do a lot of work with Stripe, the payment gateway system, and Stripe has a really good test and live system, which are identical, only the test one doesn't take any money. But they both have dashboards, they both have webhooks, so you can plug your staging system into the test Stripe and you can push real kind of customer journeys all the way through as part of a continuous integration testing process. And then when you go live, you know that it's going to do the same thing. It's just there's going to be real money going on with it. And some of the biggest frustrations I have are when you're reliant on third-party services that don't offer that capability. I'm not going to name any right now, but they exist. And it's like, so you've got production or nothing. You're telling me I can have live ammunition or I don't get to carry a gun. But there's no blanks, no props, no replicas, no fakes. It's production or it's nothing. And they're like, And it's like, well, that kind of, I don't like that, you know? I like being able to simulate everything and also to automate the process of simulation against an environment that is as accurate as possible, a replica. And, you know, the last thing I'll say on this, don't create that environment by hand, because then it will drift. And by the end of the week, it won't look like production anymore. And with the best will in the world, there are always going to be somebody is going to do something on prod that isn't reflected anywhere else. And the only way really to do that is, one, you lock down production so that no one can touch it. The only way to get stuff into production is to push a script into a repository or, you know, some Terraform or some database migration code. It has to go through the process. It has to form part of the repo where you manage all your infrastructure. And then when you create your replica environments, you do it by running the same code against an empty, environment platform. And it's right. We need database, we need web servers, we need Redis, we need this, spin up one of those, create an email gateway, all that kind of stuff, because then you know you can always make another one. And it's remarkable, not just the improvement that had in terms of the, you know, agility of the team being able to rapidly come up with things, get them done, get them built, and get them deployed, but also just, you know, it made everything happier because people aren't worried. You're not constantly having that, we got to deploy this, but, you know, in the back of your mind, you're a little bit, I'm a bit worried about what's going to happen when we try and put this live. And I think we're probably going to be here until very late at night. And then, you know, when you start getting a decent sort of set of deployment infrastructure and standards and protocols, and like you said, a people, process, and product. And when you kind of get a trust all three of those things, it's like, yeah, it's going to work. I can concentrate on building good features and stuff instead of worrying about what's going to happen when we try and put this thing live. So yeah, and I still, you know, I do sort of, you know, big replica environment stuff, even down to little things like just overriding one email address so you can run unit tests that think they're sending email and they're not. Or you're just running to something like Mailtrap. But that's what I'm always looking for, is how can what's the earliest point where I can run this code and see if it's going to fail? Because a lot of, you know, historically, a lot of organizations live in production would be the earliest point. Up until that, they are crossing their fingers and they are hoping that when it goes live, it's going to be okay. And the more you can bring that further ahead in your process, the earlier you know about it, the cheaper it is to fix. You know, I can't remember who said it, but it's if you find a bug right after you've written the line of code, the cost of fixing it is effectively zero. If you find a bug after it's gone into production, the cost of fixing it is probably thousands. If you find a bug after it's been baked into the embedded firmware that's on the MRI scanners that are in all the hospitals in North America, the cost of fixing that bug is now in the probably hundreds of millions of dollars. And so I want to find the bug now. I don't want to find it later when you know, it turns out that someone in production went, oh, that's interesting. And yeah, you know.
Awesome. Yeah, I love that you stated something like the best configuration is the one that makes you happy and you are staying happy as everything works, right? So let's finalize our discussion by maybe some extra advice, some extra recommendation from your side. What to look at, like do not deploy on Fridays, what to learn, how to learn, anything you can share with our dear participants for them to stay happy as DevOps engineers.
Understand database locks. That's literally, I think, the one thing which I've seen more immediate improvements. You know, you got a system and it's too slow and everyone's really unhappy, and somebody comes in and it's like, what did they just do? That was like magic. Like they made all the problems go away. And, you know, maybe 80% of the time that person understands database indexes and database locks. And as long as you're running on relational databases, which with all respect to the NoSQL and the document database movement, I like relational databases. They've been solid, reliable deployment platform for corporate data and stuff for decades now. They're a very, very well understood model. They work with a lot of different integration points and things. And yeah, understanding locking and tuning will just unlock a whole, no pun intended, a whole new world of, wow, actually databases are pretty amazing and they do some astonishing things. A lot of people, they get something like Microsoft SQL Server and they use it without really understanding. And it's like, it's like going and buying a Ferrari and then you never learn how to take the handbrake off. And so everywhere you go, you're doing 20 kilometers an hour and there's this horrible smell. And then someone goes, look, clunk. And you're like, oh, wow, I had no idea. And I think, a lot of people, particularly if you come into development from sort of a front end and you work your way back. So you start off with maybe some, HTML, JavaScript, and then you start doing some, back end, and then you start doing data storage. And, database, we have object relational mappers and we have active record. And there's this very, very kind of popular conception that a database is something you don't have to think about, that you just object.save, object.load, object.find, and it'll do everything for you. And that's brilliant for prototyping. And it's brilliant for building, proof of concept systems and getting something up and running quickly. But then really, you then need to go through and go, right, what's this thing actually doing? And how can I make sure that it's... So we're getting all the benefits of that incredibly sophisticated and powerful platform that we have, invested in as part of our hosting infrastructure. And let's actually, let's take the handbrake off. Let's make sure we're not driving the Ferrari with the brakes on. So yeah, there's 1,000,001 awesome things out there that I recommend everyone go and learn all of them all the time, because learning things is fun and they're all cool. But if there's one thing that I think you should go away and read up on, it's database transaction locks and database index tuning.
That's awesome and very practical recommendation. Yeah, thanks to you, Dylan. And let's be happy, let's stay happy, and let's spread our attitude for all people around us. Thank you very much, Dylan, for joining this Cloud Builders DevOps edition.
Thank you very much for having me. It's been a great pleasure. DevOps.
Yeah. By the way, see you in person in Oslo in beginning of December at NDC Oslo conference.
NDC Oslo, end of December. I'm going to be in Copenhagen 2 weeks' time for GoTo. Week after that, I'm going to be in Vilnius at Build Stuff. So if any of you are there, come and say hi. Both really, really fun conferences. And then, end of November is NDC Oslo, which is, I think, going to be the biggest event since the whole pandemic thing happened. It's the Oslo Spectrum Arena, 3 days, 9 tracks. Loads of amazing speakers, and it'll just be great to see everybody again. So yeah, if anyone's at any of those, come and say hello. It'd be great to meet you.
Coolio. Then have a great evening.
Take care, Max. See you soon.
Okay, folks, what's next? If you remember our agenda well, we had to have our second Fireside chat with Osama Mustafa. This will not happen, folks. Osama's flight was rescheduled, and he urgently ran to the airport, and he even recorded some mini session for us, but we as a production team decided, since this is not a fireside chat, right, not the real one, we better invite Osama on one of our next events, and we will also share what he recorded, like 10 minutes of answering your questions in the follow-up email. So this will be one extra motivation for you to read this email carefully. On that, that means that we are finalizing our amazing, I hope you also think that this is amazing, Build Up DevOps edition, or Build Up 8 edition. And we want to hear from you. What emotions do you have after this event? Did you learn something new? Did we inspire you to learn about DevOps, to start learning, maybe learn something deeper? In the follow-up email, you will also receive a link to the form with this short survey, or maybe my colleagues will share the link right now in the chat window. Please give us your feedback. This is something that inspires us to run more events like this one. I want to say thank you very much for all attendees, all organizers, and sponsoring company, Intellias, for supporting and joining our Cloud Builders community. Big kudos to organizing team. Of course, like I was the only one visible today, right? But there is whole team work hard under the hood to make this event happen. Production team, organizing team, kudos to you folks. I really feel supported, and I believe all the speakers can do the same. And dear Cloud Builders, fellows, remember we are moving to new knowledge with each new build-up. Stay tuned for great achievements. Maxim Salnikov was with you that evening. Bye-bye.
What we do here is go back.